more predicting with linear equations. It's a pain. Is there an easy way to do it with our calculator? Of course there is. You could also use Microsoft Excel, which just takes a little bit of time. Put the data in just like you see it. It's a hassle, but it's not the end of the world. So we did not do this in our previous lesson. We did it in a warm-up in class. We know what this is, but people watching the video may not. Let's see if we can do this with the calculator, and then let's see if we can predict. And let's change 2010 to 2011, because it is the year 2011. So here's the rules. And we will use our online calculator. So the first rule is to press the stat button. Hit enter where it says edit. Okay. And we've got a couple lists. Unfortunately, a lot of times there's something in there. See if we can clear them. Hit the delete button a bunch of times. Go over to this one. You can actually just write over these. Might as well delete. All right, so putting the years under L1. So that's 1991. 1992, and so on. Notice I don't put 2010 in because we don't have a data point for that. 252. All right, they line up, look good. So hit second and quit, so we get out of there. Hit stat again, and move the cursor over to calc, so we'll go to the right one. There's calc. We go down to number 4, and I just clicked 4. We get linreg ax plus b. Linreg stands for linear regression, which is what we've been doing, fitting a line to data. And before we do anything else, we hit the second, and then the L1 under the number 1. So second, and you see the L1 up there, get L1. We hit a comma, which is right here, then second, L2. So we're telling the linear regression to be done on the data from list 1 and list 2, which we put in earlier. Now we hit enter, gives us the equation, y equals ax plus b. A equals 2.57, B equals negative 4858. We'll round. There it is. Y equals 2.57 minus 4858. And that is a pretty good number, a pretty good equation to give us our numbers. Now, again, we're going to use 2011. We did this the other day in class, and we got y equals 3x minus 5721. So let's take the year 2011 and put them into both. There's supposed to be an x here. So y equals 2.57 times 2011 minus 4858. Y equals 3 times 2011 minus 4858. This says 310.27. This is supposed to say minus 5721. This says 312. Now, for those that don't know, this is a study of American population, which goes up quite nicely linearly, which it shouldn't. Population growth should be exponential, but it isn't. So, the population in 1999 was 273 million Americans. According to our calculator, is now 310.27 million Americans. According to our rough hand-drawn line, it's 312 million Americans. So we're 1.7 million Americans different. And what is the real population of America today? Well, they don't really know. They're just guessing too. Not until they do a census. Everything else is also just a mechanical, mathematical guess. So anyway, our hand one was pretty good. Our calculator one's a little more accurate. It's helpful. Moving to the other side, what's the zero of a function? Well, if we have a function, and I'll just put in a random equation, the zero of a function is when we go 0 equals, and we solve. We've done this before. But we didn't call it the zero of a function. We put in 6, we get out 0. So, what I just did, if you're given a y equals equation, substitute 0 in for y and solve. Y equals 4x minus 3. We go 0 equals 4x minus 3. Add 3 to both sides. 3 equals 4x. Divide 4 from both sides. X equals 3/4. If you're given an f of x, and it confuses you, change it to y. And same thing, sub 0 in. We just did that up above, so we don't need to do it again. Now, why bother? What are we talking about here? Find the zeros for each equation. Do a quick graph. What does a 0 mean? Well, I can graph this real quick here. And graph this one real quick here. Three x minus 4, 1, 2, 3, 4, 1, 2, 3, and over 1. Negative 1/2 x plus 4, 1, 2, 3, 4, down 1 over 2. And then let's actually solve them like we said we would. 0 equals 3x minus 4. 4 equals 3x, divided by 3, x equals 4/3. And over here, 0 equals negative 1/2 x plus 4, subtract 4, negative 4 equals negative 1/2 x, multiply by the reciprocal, cancel, cancel, cancel. Negatives cancel, x equals 8. So what does the 0 mean? That's where it hits the x-axis, x equals 8. Over here it hits at x equals 4/3. So when we say the 0 of something, we want to know where it hits the x-axis. A lot of solutions to a lot of math problems involve finding the 0 of things. We spend a lot of time doing this concept in Algebra 2, so we're just introducing it here. That's it. Good luck.